Okay, we're going to do the last two questions of this analytical geometry grade 11 exam question. And let's just start with the first one. It says, state the coordinates of S if PQRS is a parallelogram. Well, when they say this PQRS is a parallelogram, what you should do is go from P to Q to R in the order it is, and then you'll realize that S, the thing point they're looking for, must be out here. The only way you could do it in this order, you couldn't have a parallelogram down here. It's P, Q, R. S must be somewhere up here. That's the first thing to get. But you know what? In fact, the secret to this whole thing here, to figuring out this question, is just to look at what's happening from Q to R. And to go from Q to R, to go from, sorry, Q to P, to go from Q to P, look at this side. If we do exactly the same thing with R, the exact same change that happened from Q to P, the whole thing's going to work out. And look, what did we do? We went from -1 to -2. That's one to the right. And then we went from -2 all the way up to 2, -2 all the way up to 2. That's 4 up. Well, all we do is we do exactly the same thing to R. And if we do that, if we go 1 to the right and 2 up, then that's what's going to happen. We'll go 1 to the right of 3, and we'll go 4 up from 0, and there's my answer, 4 and 4. It's only 2 marks, so it's pretty easy. Whatever happened to Q, figure out to get to P, do the same thing with R, and you'll get your answer. That's got to make a parallelogram, because there you have it. Same gradient of 4 over 1 makes the same parallel line, so it's a parallelogram. Okay, let's look at the last question. It says, determine the equation of a line which passes through M. We worked out M is 1 and 1, but it's parallel to PQ. Well, the secret to this one, we know the gradient of PQ. The secret is when they say parallel, they're talking about a line that goes through M. Maybe I'll just draw it in here. A line that goes through M. I'll draw it in a little red dotted line here. A line that goes through M that's pointing right in the same way as PQ. Okay, so there's a parallel line going through. Well, the key to parallel lines, though, with gradients, is the gradients must be exactly the same. So what you can say, if PR is parallel to PQ, the gradient of PR must be 4. Well, whenever they say the equation of a line, write down y minus y1 equals m times x minus x1. Now you know the gradient that's got to go here. You've got the point, 1 and 1. You just put that in, and then you've got your answer. 4 times x is 4x. 4 times minus 1 is minus 4. We add 1 to minus 4. That's why we've got minus 3. And there's the equation of the line that's parallel to PQ, because it's got a gradient of 4. But it passes through 1 and 1. And there it is, all done. So I hope this helps.